All right, welcome to the lunchtime video where I learn about the JNCIE-SP. The last video, I had completed the topic of event options. So we set up a script to try to get R1 to reboot. Let's see if that script worked. Nope, so it looks like it didn't reboot, or if it did, it didn't recover the CLI. We had that bug in the last video where it loses the CLI on there. But it's not that big of a deal since I can get in through the Ubuntu Docker guest. Or at least I thought I could. I'm not sure what's going on there. I'm just going to do the whole reboot right now because it looks like most of my devices are having problems. Okay, so I need to make sure that I reboot the virtual machine. So here it is. So just need to hit restart. Yeah, previously I've been doing it in the GUI in there. I just don't think it's necessary. Kind of, there are, like for example, with that sudo GNS3 restore command, there are situations where you don't do it exactly right, it can go wrong, which is why I was doing it in that GUI. But I've done this a few times and it seemed to have been working fine. So I think it's safe to use, which is good news because it saves a bit of time. All right. So this should be disappearing soon because the server is no longer reachable because it's rebooting. All right, so it looks like the reboot went through fine. I'm not sure why I didn't lose access, but I've got my CLI back to router 1. We can see it's going through the reboot. I'll have the Ubuntu Docker guest up now, though. That reboots up really nice and fast. Okay, so yeah, everything I think is good to go. So yeah, we tried doing that script last time, or maybe not the script, but we tried doing the configuration that was the event option to have it reboot upon a certain event, that event being the clock ticking midnight. But there was some issue. I don't think it's going to be that important for me to have that working for the test. It's a test on, there's going to be other topics I need to go through, so I can't spend too much time on any particular topic. Especially if I feel like I've got the gist for it, or that if I did need to do it during the test, I could figure out how to do it, which I do feel is the case with that. But with on-box Python scripts, I think it's worth going over again. And I'd like to use the same strategy I've been using before, where I do the help apropos to learn about the topic. But it is going to take a while for it to boot up. I guess in the meantime, what I can do is, oh, well, of course I can make my title and my tags. Okay, so this is for automation scripts. It's going to be Python onbox OP. Great, so I can add Python to my tags. And I can also add SNMP to my tags. All right, so let's look up some documentation since this is gonna still take a little bit of time to load. Before I do that, let's see if we've got the Radius server still running. Oh, yep, so it wiped out all of the packages we had, so we can reinstall those. Okay. Oh, yeah, I'm not sure what FreeBSD is, but I need to do free radius. Okay, so we're back onto the CLI now. All right, so I can use the root to go in, even though I don't have radius up. All right, so let's do that same strategy where I do help apropos to learn about the topic. Okay, so we don't get on any matches for Python. Let's do it for another aspect of this topic. So onbox OP, commit, event, and SNMP. So let's try OP. Oh, so we're going to have false matches because everything is going to match OP. So let's do pipe match OP so that there's spaces around each of it. Aha, and now we get help reference system OP. So here's everything we can do for the OP scripts. We got a file with file name. And then, yep, so for JUNOS OS OP scripts, configure an operation scripting mechanism. Related topics, storing and enabling scripts. So yeah, that was fruitful, I think. Let's see if there's help for commit scripts. Okay, so yep, we've got lots of really good help here. So let's start with the benefits. Advantages of using commit scripts: reducing human error in a network configuration can significantly improve network uptime. Commit scripts enable you to control operational practices and enforce operational policy, thereby decreasing the possibility of human error. Restricting router configurations in accordance with custom design rules can vastly improve network reliability. Consider the following examples of actions you can perform with commit scripts. Basic sanity test: ensure that the edit interfaces and edit protocols hierarchies have not been accidentally deleted. Consistency check: ensure that every T1 interface configured at the edit interfaces hierarchy level is also configured at the edit interfaces RIP hierarchy level. Dual routing engine configuration test: ensure that the RE0 and RE1 configuration groups are set up correctly. When you use configuration groups, the inherited values can be overridden in the target configuration. The commit script can determine if an individual target configuration element is blocking proper inheritance of configuration group settings. Interface density: ensure that a channelized interface does not have too many channels configured. Link scaling: ensure that SONET/SDH interfaces never have a maximum transmission unit MTU size less than 4 kilobytes. Import policy check: ensure that an interior gateway protocol, IGP, does not use an import policy that imports the full routing table. Cross-protocol checks: ensure that all labeled distribution protocol LDP-enabled interfaces are configured for an IGP, or ensure that all IGP-enabled interfaces are configured for LDP. IGP design check: ensure that level 1 intermediate system to intermediate system, ISIS, routers are never enabled. Oh, that's interesting. So they want you to never have level 1 ISIS enabled. When a candidate configuration does not adhere to your design rules, a commit script can instruct the JUNOS software to generate custom warnings, system log messages, or error messages that block the commit operation from succeeding. In addition, the commit script can change the configuration in accordance with your rules and then proceed with the commit operation. Consider a network design that requires every interface on which the International Organization for Standardization, ISO, family of protocols is enabled to also have multi-protocol label switching and PLS enabled. At commit time, a commit script inspects the configuration and issues an error if this requirement is not met. This error causes the commit operation to fail and forces the user to update the configuration to comply. Instead of an error, the commit script can issue a warning about the configuration problem and then automatically correct it by changing the configuration to enable MPLS on all interfaces. So perfect. This is exactly what I mean. by some of the running themes in this channel, and one of them is oh, I forget what it was exactly, but it's exactly this. You want the commit script to issue a warning about the configuration problem instead of actually causing the error and reducing your uptime. A system log message can also be generated indicating that corrective action was taken. Another option is to define a macro that enables ISO protocols and MPLS when the macro is applied to an interface. Configuring this macro simplifies the configuration task while ensuring that both protocols are configured together. Finally, you can have the commit script correct the configuration using a transient change. In our example, a transient change allows MPLS to always be enabled on ISO-enabled devices without having the configuration statements appear in the candidate configuration. All of these example scenarios are included in commit script examples. Transient changes cause a change to be generated in the checkout configuration, but not in the candidate configuration. The checkout configuration is the configuration database that is checked for standard JUNOS syntax just before a configuration becomes active. This means transient changes are not saved in the configuration if the associated commit script is deleted or activated. The show configuration display commit scripts command displays all these statements that are in the configuration, including statements that were generated by transient changes. For more information, see configuring a persistent or transient configuration change. Okay, so I really like this note. We'll include this in the notes for this video. Wait, and then I'm going to turn up my air filter because there's something in the air kind of messing with me. All right, so hopefully that's not too loud in the background there. Let's keep moving. All right, so those are the benefits. Let's see some examples analyzed. The following examples illustrate how commit scripts work. Each example is followed by a line-by-line explanation. The first example, the following script applies a transient change to each interface whose name begins with SO-, setting the encapsulation to PPP. Okay, and this is, remember that there's two languages. There's the Slacks language, and then there's another language that is more based on XML. In addition to that, there's also Python. Got a fly problem here, but I am able to handle it. All right. So in addition to that, you can also use Python, but you've got to enable Python in the configuration first. Also, there really aren't that many examples for how to use Python on Juniper. The built-in help is mostly going to show you either this XML language or Slacks. Okay, so I would like to do one of these examples. One thing, so let me take a note of the things I would like to do. So I can get rid of these netconf goals here because they're all done. And let me write down some some goals for onbox. So we'll just call it onbox goals. Okay, so we've got OP. So let's make a goal for each kind of script. So OP, we've also got commit. We've got event. So event, I think I can mark done already because we did the one that it didn't run, but I think we got a decent sense of how to configure an event script. But I'll just leave it for now. And then we've got SNMP. So let's label them all not done. And then not done. Not done. Not done. Okay, and then let's make a goal for each of these scripts. So let's do a Google search to kind of find what the best goal might be. So actually, before we do that, let's use the built-in help to do that. So here, yep, we've got this help reference system OP. Let's do a help apropos. And let's do scripts. Or just script, because it might be able to match on scripts if I do that. Okay, so yep, here we go, commit scripts. But, aha, here we go, now OP scripts. And then, yep, so event options, so that's event scripts. So let's make some notes of all those, because those are exactly what I'm looking for. So we've got, okay, and let's do a, yeah, let's do a match on dash scripts space. There we go. So now it's more, yep, so here we go. Okay, so we've only got 3 kinds of scripts here. I'm going to remove the formatting from here. Okay, and then hopefully I can clean up these pipes somehow. Maybe I can use Python to do that. Okay, so now we can do a for I in cleanup, or for character in cleanup. So if character is a pipe key, continue, else print character. Oops. Don't want to print it on a new line though. Okay, so let's go back here and let's do results equals append, and then we'll do here, and then we'll do results.append character. Okay, so now we've got results. Okay, so results is a list, which is fine. We can make it into a string. Equals dot join results. Okay, so this should look a lot better. There we go. Now we've got all these extra spaces in there though, and we've also got some extra new lines that we want to take out. So let's take those out. So we can do for, oh, actually what we can do is we can split, we can do results dot split, and then we're going to split it based on a space. There we go. So, and then we can do so yeah, we can do results list equals there, and then we can do we can just remove all new lines and spaces, and then we can join the list back into a string without any of those. We can join it using a space. So that should work. So let's do that. So for character in results list, or let's say for word, because we're going to have individual words, or either that or we're going to have spaces. And we're going to join the individual words together with a space. So for word in results list, oh, and let's have a final results. Okay, so for word in results list, if word does not in, and then here we've got our options of what we don't want to be included. Okay, so if that's true, we're going to append it to the final results. Okay, so now we've got our final results with just the words. So we're going to do print, and then we're going to join them together with a space. Final results. There we go. And now we've got notes more like what we are looking for. Perfect. Looks like there's an extra new line in there somehow, but it's easy enough to just erase. So now we can add quotes around this. Yeah, so no, unfortunately this will not be cited, but it's just for me. It's not meant to be. It's not, I don't think citations are super important in this case. Yes, to help me go back to it later, they will be important, but most important is that transient changes cause a change to be generated in the checkout config, but not in the candidate config. That's the most important thing to know. Okay, so, yep, so we've got help for commit scripts, OP scripts, and event scripts. We also need help for SNMP scripts. So let's do a up arrow on this, and they'll do a pipe match SNMP. So there isn't anything for that. Let's do a help apropos SNMP pipe match script. Okay, don't see anything there either. So I guess that'll be fine. We'll just, if we have the opportunity to use SNMP in the script, we'll do that. So the first thing we're going to need to do is enable Python scripting. So edit system scripts, set. Oh, so here's where we can do for SNMP scripts, but to enable Python scripting, you've got to do set language, Python. Okay, so now let's work off of these helps and see if we can set a goal for each of these, and hopefully accomplish one or two of them before the lunchtime video ends, but I think that'll be a bit too ambitious. We'll have to wait until the after work video to accomplish those goals. But hopefully we can accomplish them simply in the after work video and then move on to interface configuration and so move on to the next topic. But for now, that's getting a bit ahead of myself, so I will continue to focus on the task at hand, which is creating goals for these unbox scripts. So let's create a goal for the OP unbox script. JUNOS automation scripts automate network and router management and troubleshooting. Automation scripts can perform any function available through the remote procedure calls, RPCs, supported by either of the two application programming interfaces, APIs, the JUNOS Extensible Markup Language, XML API, and the JUNOScript API. Automation scripts allow you to do the following things: diagnose and fix network problems automatically, monitor the overall status of a routing platform, customize the output of operational mode commands, reconfigure the routing platform to avoid or work around known problems in the JUNOS software, change the router's configuration in response to a problem. This chapter includes the following topics: automation script programming, automation script types, storing automation scripts, how OP scripts work, using automation scripts. Okay, so let's try to get a deeper dive into here. So let's do a help apropos. So I'm not sure what all this is, so I will search for it. Put it in my notes first. So this is important because it's a required boilerplate for all OP scripts. When you write OP scripts, you use extensible, and I'll get a better format of this. Okay, so when you write operation scripts, OP scripts, you use extensible style sheet language transformation, XSLT, or style sheet language alternative syntax, SLAX tools provided with JUNOS OS. These tools include basic boilerplate that you must include in all OP scripts, optional extension functions that accomplish scripting tasks more easily, and named templates that make scripts easier to read and write, which you import from a file called junos.xsl. For more information about the extension functions and templates, see JUNOS script automation, understanding extension features in the JCS and SLAX namespaces, and JUNOS script automation, named namespaces in the JCS namespace overview. OP scripts are based on JUNOS XML and JUNOS XML protocol tag elements. Like all XML elements, angle brackets enclose the name of a JUNOS XML or JUNOS XML protocol tag element in its opening and closing tags. This is an XML convention, and the brackets are a required part of the complete tag element name. They are not to be confused with the angle brackets used in the documentation to indicate additional parts of JUNOS OS CLI command strings. You must include either XSLT or SLAX boilerplate as the starting point for all OP scripts that you create. The XSLT boilerplate follows. So, okay, so this boilerplate is required for everything. So I'm going to add this to my notes because this is pretty important. I think they might give it for Slacks as well. Nope, I don't see it for Slacks. I only see it for XSLT, but let's add that in there. So XSLT boilerplate, we'll call it. Okay. All right, so here it explains it line by line, what everything means. Not super long, so I think I'm going to read it all. Line 1 is the extensible markup language, XML processing instruction, PI, which marks this file as XML and specifies the version of XML as 1.0. The XML PI, which stands for processing instruction, if present, must be the first non-comment token in the script file. So this is line 1, and it's the XML PI, processing instruction. So it specifies the version of XML 1.0. Okay. So, and this must be the first thing you have in your script, besides anything prior that is commented out. Line 2 opens the style sheet and specifies the XSLT version as 1.0. Lines 3 through 6 list all the namespace mappings commonly used in operation scripts. Not all of these prefixes are used in this example, but it is not an error to list namespace mappings that are not referenced. Okay, so just like in Python, where if you import an extra module and you don't use it, it's not going to cause an error. Listing all namespace mappings prevents errors if the mappings are used in later versions of the script. Okay, so these are the namespace mappings, and you don't have to include the ones you're not using, but it looks like there's only 4 of them, so if you include all 4 and you decide to use them later, you won't have to add them later. And not only that, including them extra does not cause any issues. Line 7 is an XSLT import statement. It loads the templates and variables from the file referenced as this, which ships as part of JUNOS OS. The JUNOS XSL file contains a set of name templates you can call in your scripts. These name templates are discussed in JUNOS script automation, name templates in the JCS namespace overview, and JUNOS name templates in the JCS namespace summary. Line 8 defines a template that matches the open chevron / close chevron element. The element is the root element and represents the top level of the XML hierarchy. All XML path language XPath expressions in the script must start at the top level. This allows the script to access all possible JUNOS XML and JUNOS XML protocol remote procedure calls, RPCs. For more information, see XPath overview. After the tag element, the OP script results and the OP script results container tags must be the top level child tags as shown in the lines 9 and 10. Line 11 closes the template. Between line 11 and line 13, you can define additional XSLT templates that are called from within the XSLT template. Line 12 closes the style sheet and the opt script. I think I'm using Windex to handle my bugs, and I think there's just like not enough ventilation in here, and I'm like breathing Windex or something. So I'm going to start by turning my fan on, and then I will open the door. I'm going to pause the video quick. All right, now I got the door open to the hallway and the fan on, so hopefully I will feel better. It just felt like I wasn't able to get a deep breath for a while, probably because there's too much Windex in the air. So hopefully this will make things better for me. The corresponding / boilerplate is as follows. Yeah, this does feel up here. Oh, okay. / boilerplate for OP scripts. All right, so that's it for the boilerplates. It looks like I've only got about 15 minutes, probably a lot less, until the lunchtime video's got to come to an end. But we've got, so we've got the radius back. So I think I'll enable that just because. Okay, so I'll make a new user under John Doe. All right, and then I need to allow my server to, my client to authenticate to my free radius server. So that's going to be in clients.conf. Okay, so I think that's right. Let's check that it's, yep, so that is the correct password. Okay, so now let's get screen. Oh, looks like we got another fly. Well, I do have some glue paper. It looks like that one is a bit more agile than the other ones, so we'll put out a glue board and maybe it will land on it. Okay. See if that works. That has a pretty strong smell too. Okay, well, I want that fan to be a little bit stronger. That glue board is smelling as well. But let's continue on, hopefully. Hopefully I don't need to take a walk outside soon, but I will do that after this video. Okay, so yeah, everything I think is good to go. We still want to create some sort of goal for OP scripts. Okay, so let's do a Google search, and hopefully that will be enough to find a goal. So Juniper OP scripts. So when I was studying for 961, I did learn about OP scripts already, and I do remember something where every time you commit, it backs it up to a local server. So if I could do that, that would be, I think, a really good one. Okay, so this looks like a good one. Every time somebody logs in, you get an OP script running. Here we go. This looks like a good one. Python automation scripts. Yeah, this looks right. Okay, so yeah, I think I'm just going to save a lot of this configuration, and then in the after work video, because I'm not sure I'll be able to find the goal now. Well, actually, no, I think I can find one. So I think the goal is going to be alert to a server whenever a user logs into a box. And I guess we can have it. Yeah, okay, so that's a good enough goal. So let's, yeah. Okay. Okay, here's the boilerplates required for each of the 3 kinds of scripts we'll be studying. We'll also be studying a SNMP script, but that's not listed in this documentation. So hopefully I can skip right. No, I can't skip right down to the Python boilerplate. It looks like it's the same boilerplate. Nope, it's quite a bit different. Oh yeah, it's quite a bit different, especially for event scripts. Okay, so that's probably going to be the most important thing. In fact, once we have the boilerplate, we'll be able to go off on our own and just figure out on our own what is the best thing to do. The other thing that I think might be helpful is the Juniper Day 1 automation guide. Okay, well, say JUNOS Python library. Okay, so yeah, I think I've got things pretty much gathered up for the after work video where I'll be setting up this boilerplate, and then I'll be just trying to understand what I can do by reading the help documentation, the developer guide here, so I'll include that in my notes as well. Yeah, so I'll see you in the after work video. Hold on a second. All right, so I will see you in the after work video. Thanks for watching, and I'll see you next time.